Imagine you're on a commercial flight, cruising at 35,000 feet, when suddenly a hijacker commandeers the airplane and demands to be taken to the moon. This is no ordinary hijacking. This is a scenario that stretches the boundaries of imagination and takes us into the realm of the extraordinary. But is it really possible? Could a commercial airplane, designed to ferry passengers across continents, actually traverse the vastness of space and land on the moon? It's a question that invites us to explore the fascinating worlds of aviation and space travel, to delve into the science behind how airplanes fly and how spacecraft journey through the cosmos. It's a question that challenges our understanding of what's possible and what's purely the stuff of science fiction. So buckle up as we embark on this thrilling journey of discovery. But can a plane really fly to the moon? Let's find out. To understand why a plane can't fly to the moon, we first need to understand how planes fly. Airplanes are marvelous machines, engineered to take advantage of the Earth's atmosphere and the principles of aerodynamics. The most fundamental of these principles are lift and thrust. Lift is the force that directly opposes the weight of the plane and holds it in the air. It's created by the flow of air over the wings, which are specially shaped to make air travel faster over the top than the bottom. This faster movement creates a lower pressure area above the wing, and the higher pressure beneath lifts the plane into the sky. Thrust is the forward force that propels the plane through the air. It's produced by engines which suck in air at the front, compress it, mix it with fuel, and ignite it. The resulting explosion pushes the air out at the back, and due to Newton's third law of motion, for every action, there's an equal and opposite reaction. The plane is pushed forward. But lift and thrust aren't the whole story. We also have to consider drag, the resistance encountered by the plane as it moves through the air, and gravity, the force constantly pulling the plane towards the Earth. A successful flight is a delicate balance between these four forces. Now, these principles work perfectly in Earth's atmosphere because it's full of air. Air for the wings to create lift, air for the engines to create thrust. But space is, well, space. It's a vacuum devoid of air. Without air, there's no lift, no thrust. A plane in space would have nothing to fly against, making controlled flight impossible. So, as you can see, flight as we know it relies heavily on the Earth's atmosphere. Without it, our usual methods of aviation simply don't apply. The science of flight is a fascinating field, but it's firmly grounded in the conditions provided by our home planet. When it comes to journeying beyond, we need to look to a completely different set of principles and technologies. But what happens when we leave the atmosphere behind and venture into space? The first hurdle in our hijacker's moonbound journey is the concept of escape velocity. This is the minimum speed an object needs to escape the gravitational pull of a celestial body, in our case, Earth. For us to break free from Earth's gravitational embrace, we need to reach a blistering speed of approximately 25,000 miles per hour. To put that into perspective, a commercial jet flies at a cruise speed of around 560 miles per hour. That's a substantial speed deficit our hijacker would need to overcome, and no commercial aircraft can bridge that gap. But let's imagine for a moment that our plane miraculously achieves the required speed. We then face another set of problems, the harsh conditions of space. Earth's atmosphere acts like a cozy blanket, providing us with breathable air and protecting us from extreme temperatures. In space, there's no air to breathe, and temperatures can swing wildly from extreme heat to bone-chilling cold. Our commercial aircraft, designed for the comfortable conditions within Earth's atmosphere, is ill-prepared for these extremes. The plane's structure, its engines, even the passengers inside, wouldn't survive this hostile environment. And then, there's the matter of navigation. Navigating in space is a far cry from flying from one city to another. In space, we're dealing with the gravitational pull of various celestial bodies and the vast, disorienting emptiness. Our GPS won't be of much help out there, so it's clear that our hijacker's plan is riddled with insurmountable problems. The moon might look tantalizingly close on a clear night, but getting there is not as straightforward as catching a flight from New York to London. Clearly, space presents a whole new set of challenges that our hijacker hasn't considered. But let's say, just for argument's sake, that our hijacker somehow made it to the moon. What then? Imagine an environment so alien, it's like stepping into a different world. The moon is a stark, barren landscape with no atmosphere. That's right, no air, no wind, no weather, just a silent void. This lack of atmosphere means there's no air to provide lift for the wings of a plane, making it impossible for a commercial airplane to land. Now consider the terrain. The moon's surface is a chaotic mess of craters, rocks, and mountains. It's not the flat, smooth runway a plane needs for landing. Lunar dust, finer than flour and as sharp as glass, poses another challenge, capable of damaging equipment and infiltrating machinery. So even if our hijacker could get to the moon, landing there would be another story entirely. And that's not even considering the challenge of taking off again. So what would it really take to get to the moon? Well, let's start with the spacecraft. Unlike our hijacker's commercial airplane, a lunar mission requires a specialized craft designed for the rigors of space travel. Think Apollo missions, where the mighty Saturn V rockets propelled astronauts out of Earth's atmosphere and towards the moon. These spacecraft are equipped with life support systems, radiation shielding, and robust engines, capable of achieving the necessary speeds to break free from Earth's gravitational pull. Once in space, navigation becomes a complex game of gravitational influences and precise calculations to ensure correct lunar trajectory. And let's not forget about the future. NASA's Artemis program, aiming to return humans to the moon by 2024, is a testament to the continued evolution of lunar travel technology. While the scenario of a hijacker flying a commercial plane to the moon is pure fantasy, it does highlight the vast differences between air travel and space travel. Thank you for joining this journey. If you enjoyed this video, please make sure to press the like button, and if you're fascinated by the hidden tales and mysteries, please subscribe to our channel for weekly content.